Okay, you can still see my screen all right, yeah?
Yes. So
perfect, because I have two screens here. Sorry, I'm a little bit disoriented.
no, it's just it's fine. So we're delighted to have Meike Ramon with us today. Meike has done her undergraduate studies in Germany in Bochum. I'm probably not pronouncing that very well, in psychology and neuropsychology. And then she continued to do her PhD with Bruno Rossion's lab. Bruno does a lot of face perception experiments with interesting methods. So she did her PhD in his lab, and then she went to Glasgow as a visiting postdoc researcher and did her postdoc there. She did another postdoc in Switzerland, and now she's got her own lab at the University of Freiburg. At the Department of Psychology. She does a lot of face perception inquiries, and today she'll tell us about super recognizers, and we're very glad to have you and waiting to hear about your exciting research. Thank you for joining us.
Thank you. Thanks so much for the invitation. It was quite unexpected and impromptu, so I'm really glad to have the opportunity to meet with so many people. I think this is the most numerous, one of the most numerous Zoom meetings I've actually attended for the past 4 months. So yeah, I'm going to be talking about super recognizers, something that I've been fairly recently working on, and tell you something about all the things that we know, the things we don't know, and the things that I think that we really need to know. And yeah, so thank you already for the intro. I had just briefly summarized this visually, kind of mapping the stages of my work and where it took me. Yeah, and as you...
We hear you with a lot of echo. Can you
move
can you move the microphone somehow?
I'll try and take these out, and maybe it'll be better, I hope. Hold on, let me just check and see. Oops, no, I'm trying to disconnect this.
I also didn't hear any echo, and there's another person saying that there's no echo. So maybe try to continue, and maybe it'll.
I hear you very well, Medes.
Okay.
Yeah. Okay.
Okay. Is it better now?
Yeah, much better.
Okay, then I'll just leave it this way. Thanks for telling me in advance. Right. Yeah, so as Sharon said, or mentioned, basically the work that I've been doing has dealt mainly with processing of human facial identity. And I like to study faces because I think that they're a good stimulus to study different types of things about human vision. And they offer a lot of opportunities to address a multitude of different questions. And I'm really interested in the entire range of processing capacity. So while I started out with developmental prosopagnosia during my master's or diploma, and then continued on acquired prosopagnosia and moved over to personal familiarity and how that affects how we visually perceive and process faces, I've become more and more interested in like these top-down effects, or how task demands modulate visual processing, but also individual differences. And so I'm really interested in the full spectrum, and that has led me to what I'm currently doing. So I was recently awarded a project funding from the Swiss National Science Foundation, which is specifically supposed to address the mechanisms that are underlying extremely efficient face processing capacity that is not related to experience, training, or extended exposure. And for somewhat obvious reasons, this also involves collaborations with different international police agencies, because they're naturally interested in how humans process faces, as well as automatic face recognition, of course. So to give you a brief outline about the talk, and I'm just quickly throwing out some papers that are relevant if anyone wants to take a snapshot or look at the video later. I'll give you a little background information.
Sorry about that.
Sounds like music. Yeah, I'll talk about what the status quo is currently in terms of the research that we have at our disposal. on the topic of super recognizers. And then I'll really focus a lot on problems, because I think that currently there's more problems than knowledge, actually, which is exciting, to say the least. And I'll try and offer a solution and a little bit of outlook in terms of the work that we are doing and preparing currently in the lab and that we plan on doing. So also, if you have questions in between, please feel free to interrupt me. So I really like that. And I think we have quite generous time frame as well, if I understand. Right, so just to give a bit of background on facial identity processing, I don't know how many of you actually specialize on face perception, face recognition. So I just always throw out these slides to make sure that everyone's kind of on the same level. So if we think about face processing, we have to say that it's a very complex and multi-level type of processing that we do, kind of unconsciously. So we're not even aware of this. And what I mean by this is that we process faces at different levels with high efficiency. So at the very most basic level, we have to detect the presence of face. The next level, we can categorize them according to different dimensions, such as their gender, ethnicity, intentions, emotional state, and so forth. But then the more interesting level for us who are dealing with facial identity processing are different processes. So our ability to discriminate between individuals, to say that these are actually different people, or our ability to recognize that an individual or an image has been previously seen. So before I showed you that array of faces, and perhaps you recognize that you'd actually already been exposed to this individual. And then finally, at the apex of this processing cascade, you would also be able to identify faces. So if you know me personally, you might have been able to recognize this as being a much younger version of me, despite never having seen this picture before. So this kind of shows some of the different types of things that we can do with faces. Most of these processes are usually quite effortless. Identification relies to a high degree on personal familiarity or previous exposure, and usually the other processes are quite efficiently done. And this is obviously not only relevant under these lab conditions where we test these sub-processes, but this is kind of the type of processing that a lot of people do for professional reasons, such as passport control officers, when they have to verify the identity of a person that they're confronted with to a given image, and they have to make a decision whether it's the same person or not. Or when, for instance, witnesses or victims of crimes have to recognize perpetrators under very difficult conditions because of degraded information, low resolution, emotional involvement. So there's a lot of different ways that these processes are relevant in our real life. And we also know, based on this experience, our own experience, but also things that we've heard in the media, that face processing is actually very error prone. So that shows how complex the tasks are, despite the fact that we think that we are experts and we are very efficient at this. So both humans as well as machines make a large number of errors, and there's actually there's several reports of people accidentally traveling with the passport of their different gendered spouse. So a woman only arrived in Spain or Turkey, in this case, to realize that she had accidentally traveled with her husband's passport, and this didn't even go noticed at the airport. But we also have probably all heard of a lot of the very problematic, difficult mistakes that can also happen when we're dealing with automatic solutions. And for these reasons, I think it's really important to understand better the mechanisms that are underlying human face processing in general, to minimize the errors and to understand the implications that they can have. And one component that's really critical in this understanding, in my opinion, is really focusing in on the individual, because there's obviously a lot of noise that we try to cancel out, but I believe that there's a lot of information that's also relevant and that we need to fully capture that relates to individual differences in processing across these multiple levels of processing. So yeah, today I'm going to be talking about so-called super recognizers, or SRs, as I will abbreviate this from now on. And these are people who were thought to have a naturally occurring superiority in terms of face processing. So these are not people who have undergone extensive training or practice face recognition like some memory champions might do. This is really without any type of special focus on faces. They somehow seem to excel at this relative to their peers or their social group in comparison. And if we look back on when super recognizers actually first emerged, it's actually quite recent. So in 2009, Richard Russell, Brad Duchenne, and Ken Nakayama, they had published this paper, which was a brief report, and it was kind of an accidental finding. So they were in the process of developing tests that were geared to identify developmental prosopagnostics. This is my understanding of the process. And they came across these people who were reported to them as being extremely superior or really good at face processing. And they reported a handful of these people who seemed to be different than the controls that they had tested previously. And so these three guys are, plotted on this graph. And the tests that these people excelled in were the so-called Cambridge Face Memory Test, the extended version, which is a test that requires people to encode target identities for a certain amount of time, and then later recognize in an old-new paradigm these previously learned target identities under increasingly more difficult visual conditions. So for instance, with added noise, changes in facial expression, changes of viewpoint. And so this was one of the tests that these individuals, these so-called super recognizers, excelled at. And the second test was the so-called before they were famous task, where people were presented with images of well-known celebrities, politicians, whatever, before they were actually famous. And so basically images that were relatively difficult to recognize. And I don't know if you will all recognize these images. There are some quite interesting mistakes that people tend to do when I'm actually giving this presentation where people are responsive. But maybe just look at the image on the top right and say who this is.
Scarlett Johansson.
Scarlett Johansson is the bottom left.
The only one I recognize.
Yeah, so Malcolm X is the top left. I think it's James Dean on the bottom right. And interestingly, a lot of people have said very consistently throughout talks that the top right is Donald Trump, where actually it's not. I think it's Bill Clinton. So yeah, basically that was how it all began. And if we look at the number of publications that have been published about super recognizers relative to the number of publications on face processing in the most general term, over a 50-year span, we can see that there's a large number of papers that have been dealing with face cognition in the broadest sense. And a very small number of papers that has actually been dealing with super recognizers. Obviously, it's a quite new subject. And so until 2018, there were 14 papers published. And to date, there's a total of 22 papers, 7 of which were actually commentaries that were published last year in a special issue on this topic, in a target issue on this topic. And only 15 empirical studies currently exist. So we really, I would say we know absolutely nothing about this. So it's an exciting time to start work on this, in my opinion. Yeah, so that's kind of like the background in terms of the scientific research and where we're coming from. And at the same time, or kind of in parallel, there were reports of super recognizers being employed in real life scenarios. So there was a New Yorker article where they talked about this previous, to my knowledge, previous and no longer existing super recognizer unit within the London Metropolitan Police. These detectives who were super recognizers. Some of these offered their help to German police forces when they were investigating the mass attacks on women at New Year's Eve in 2015, 2016. So they had sent part of their unit there to help support processing the CCTV footage that they had. Then even more recently, Munich had said that they were using super recognizers to make the Oktoberfest safer. And finally, there's, in my opinion, an increasing interest in, again, in my opinion, dubious enterprises and fee-based associations who are trying to, utilize this increasing demand or create perhaps the illusion of a demand for super recognizers in policing. But that's something that I can talk about a lot offline. So moving on to the next topic of the talk, the problems that I see with respect to research on super recognizers. So I already said that we know little to nothing about this, and I think that this lack of knowledge in opposition to the increasing demand, which is actually present or perhaps created, the illusion of demand, is a very problematic situation, in my opinion. And I see two very fundamental problems that I'm going to talk about here. So the first one refers to a lacking conceptual foundation. So some of us who know this from the developmental prosopagnosia literature might see some parallels where a lack of a definition or a consensus regarding diagnostic criteria leads to an enormous amount of variability in the type of data, the type of cases, patients, or individuals that we report. And subsequently, then also it leads to, or can lead to, a heterogeneous pool of findings. And obviously, in the absence of a clear-cut definition or a consensus regarding diagnostic criteria, this also leads to a very inconsistent identification of these so-called super recognizers, both in terms of the approaches that people opt for, as well as the quality of the tests that are actually used. And so I'm going to talk about these two things in more detail. At the very most basic level, I think it's always important to create some kind of foundation, so to ensure that people are all talking about the same thing. So now we're all using this term super recognizers, but that doesn't necessarily mean that we mean the same thing when we use that same term. So in February, I was invited to give a keynote at the second consortium meeting of the EU project SafeSea, Safer Space in Safer Cities, public spaces and safety was the topic. I'm not sure that the acronym is accurate. And I was going to be talking to police officers from 11 European countries, and I think Israel was also present or had sent representatives. And I thought this was a really good opportunity to conduct a public poll and to see what people actually think super recognizers are. So I asked three questions, and the most important one to me was, what is a super recognizer? And I basically offered 5 possible responses. The first one, people who never forget a face. Or the second one, which is an empirically unsupported claim, which is really proliferated in the media. It's that super recognizers are 1% to 2% of the population who can remember 80% of the faces that they've ever seen before. Or the third option was people who are above average at face matching, people who excel at recognizing others using a range of different types of features or information sources. So it's more person recognition if you want. And finally, I don't know. And so I did this in parallel for the police officials who were attending the workshop, as well as a public poll. And it was quite interesting what police officials versus civilians responded. So if we look at it, intuitively, but interestingly, the police professionals said that they think that super recognizers are people who excel at recognizing people. And this makes sense, right? Because for a police officer, it doesn't matter whether they're using the face or they're identifying someone because of certain features or characteristics or gait, voice, posture, clothing. Police officers use all different kinds of features because it's the recognition of a person that's relevant. But this has obviously little to do with how the concept of super recognizers emerged academically. And in civilians, the opinions or the definitions seem to quite differ much more. But interestingly, the majority of the responses reflected these statements that are proliferated through the media. So I think that's quite interesting. So we see that there's a large degree of variety or variation in terms of the definitions that people have when they think about super recognizers. And I think that then even amongst academics, there are different conceptualizations. And also the impact of professional relevance, exposure to media, and how these things kind of can all play into our understanding of a concept. And so obviously building on this lacking foundation or definition and consensus, it is then clear that the ways that we want to identify these people with also differs highly depending on who's actually dealing with this topic. So I'm going to highlight 3 different approaches that I've experienced or come across, which A, relates to professional or peer evaluation, so people being identified as super recognizers in police settings or professional settings through peer evaluation. The second approach, which I see an increasing tendency for, and I believe is associated with a lot of problems potentially, is mass online testing. And then finally, controlled lab testing. So the way that super recognizer identification had originally started, and how it has developed and how different people are doing this nowadays. So if we think about super recognizer identification through peer evaluation or professional assessment, there's a very recent study that was published by Jonathan Phillips, David White, and Alice O'Toole as well. They were involved in the study as well. And they said, if you read the supplementary information, that there were 2 ways that people could be considered as a super recognizer. Either through lab identified or lab testing using experiments that we use empirically, or being employed currently to use their skills as a super recognizer. However, I have to say that throughout all of my experience, I have not yet heard of a single person who has been hired to work as a super recognizer. Rather, what happens is that people become aware that a certain person is good at doing something, and then they use them for that purpose, or they ask them for advice, and it's a very much experience-based utilization of resources, which obviously makes sense. However, this does not necessarily mean that this peer assessment is necessarily accurate and reflects what we think that super recognizers are. So to give one example, the head of the Zurich Cantonal Police Manhunt Unit, who deals with image comparisons daily and is known within Switzerland and beyond to be really the best person when it comes to identity processing across images. He came to me and he was quite convinced that he was a super recognizer, and I tested him, and afterwards he was like, okay, no, this is something different. This is not what I'm doing. So testing faces with very challenging experiments, that was not what he was doing in real life. So you can be highly successful in your professional setting where you might be dealing with person identification or recognition, but that doesn't necessarily a super recognizer make. Also, because your professional success could be related to a number of factors. It could be due to training, which some people undergo in the context of different police agencies. We're actually developing or continuously developing one procedure that deals with face processing and suspicious behavior detection with the Zurich police. And on the other hand, police officers usually stay in their boroughs, in their neighborhoods, and they arrest people, and they will recognize them very efficiently after they have already arrested them. This has been leading to an increased number of correct arrests. And so, I feel that we need to be cautious about peer evaluation and peer assessment and considering that someone is a super recognizer. And in fact, I had the opportunity to test one of the 3 police officers in the Cologne police who were identified by the Metropolitan Super Recognizer Unit as alleged super recognizers. And one of these 3 guys told me, I'm not good with faces. Like, I don't do face processing. I'm a former pickpocket investigator, and I can detect suspicious behavior. And I tested him with a number of face processing tests, and he actually scored 56 of 102, which is a really, well, mediocre at best result on the Cambridge test. So this really shows that, you know, what people are dealing with in police settings might not be the same as what we're doing in the lab. So then the second thing that I want to touch upon is this mass online testing of face processing skills. What we see is the use of the internet for better and worse, and I believe that uncontrolled mass testing is definitely for worse. One example, in my opinion, is one test that has been online and live and is constantly changing, consists of new tests, is one that is offered by the University of Greenwich. And according to Josh Davis's article that was published in the Cognitive Psychology Bulletin, over 6 million people have passed this test. So that's quite impressive in terms of numbers. And, you know, there are reasons why people do this, because, so this is a screen grab that I just took when I recently went on the website, because I realized that you actually get certificates of completion. And, you know, just the fact that I can take this, I can modify this, and I can create my own kind of certificate, which is assigned a signature of a renowned academic at a university. I believe this is problematic, but the issues that I more have are because of information that has been passed on to me from participants who have completed all of these tests. So one Swiss woman contacted me, and she said that she was the highest performing subject on this 12 test super recognizer challenge that they ran. So this is a screen grab from a PDF that she sent me. And so this test at one point or another consisted of 12, so this battery consisted of 12 tests, some of which I've never heard before, I can't read up on, and, you know, there are the maximum possible scores that are listed. And she told me, and she provided proof, that she was actually the top performing individual, so the rank 1 of these alleged 6 million people. And you know, she provided this to me, and I looked at the numbers, and I thought, this is a little bit interesting. I don't know these tests because some of them haven't been published before, but there's a lot of things that I personally find problematic. For instance, you know, if I'm saying that the maximum score is 60 and the number of these 500 people that were listed in the PDF score 61 or 62, that's a little bit difficult. So all of these online tests are not necessarily reproducible. I somehow question also the relevance of including a flowers or a guitar recognition test in a test of super recognizer behavior. And also I wonder whether the computation of the scores is actually accurate. So I think you'll understand the reservations that I have with regards to this type of online testing. And most recently, our colleagues, David White and Josh Davis, also had published another paper. This is an archive paper that I reviewed and have signed. This is the University of New South Wales battery, which claims to probe identification memory and perceptual matching, or recognition memory and match to sample sorting. And it includes 2 tests. So in the first one, you're supposed to encode 20 individual faces, which then after a delay period, you're supposed to recognize amongst 40 images, so 20 new and 20 old, so a classic old-new recognition test. And the second study, I was actually really excited about this experiment because I had never seen anything like this before. So you receive 20 targets to encode for 5 seconds. The target is then removed, and after a brief period, you're presented 4 images, and you're supposed to say, does any of these 4 images represent the previously presented target? And then you say, yes, put it in the left, no, put it on the right, or vice versa. I'm not exactly sure. So I quite like these tests, and I was quite excited about it because I thought, this could actually be a pretty promising battery of perception and memory, as they claim. However, in reality, these are both tests of recognition memory that are probed under different encoding and delay durations and given different probabilities. So the first one is a classic old-new recognition, whereas the second one is also a delayed matching or recognition task, which, however, includes different levels of uncertainty. So you don't know whether the target will be present, whether the target is present once, up to 4 times. So this is, I think, something different than probing perception and recognition memory. And there are, in my opinion, a number of methodological and test theoretical shortcomings, which include the conflation of processes, which include stimulus material selection, but also claims about reliability and sensitivity, because a lot of these online tests suffer from a number of issues that I quickly want to look at right now. So while, yes, of course, they offer a large number of observations, I would say that rather than diminishing noise, this actually gives us another situation where noise, if it is systematic, can be increased, and actually the influence of the noise would actually be augmented. And this is particularly relevant because we want to create methods that are reproducible and that are sound, methodologically sound. And I see a lot of lack of rigor controlling quality assurance. And just to show some of the points that I'd like to mention here are related to really procedural aspects that would not occur in controlled laboratory conditions. So first of all, participants who go online and want to do these tests are told you should not be doing this on a tablet or a mobile device, but you can. You can totally do these tests on a mobile or a tablet, and moreover, there's no screen calibration that is actually implemented. So you might be seeing something, I don't know, 4 pixels or massive, and this, just in terms of experimental, from an experimental perspective, I believe this to be very problematic because we're averaging across data points that are just not comparative at all, comparable at all. Then there's also no way to control for a repeat completion of a given test. As soon as I move from one computer to the next, the IP address changes, but the person, the observer, is the same. I will have learned from my previous exposure, and there is no way for the experimenters to control for this. And finally, and most critically, I see no way to distinguish between human and non-human respondents. So whether someone created a bot that provided 5,000 responses or 5,000 participants is, from an experimenter's point of view, not distinguishable from genuine subjects who have done this once under the conditions that they should have. So for me, this is problematic, especially if we think about this being designed for selection of employees who were supposed to do some security critical work, namely in policing or identifying criminals and suspects. And this situation actually made me think of a quote that I heard, or that I read about, an Alfred Binet quote, who was saying, you know, some authors love to do things big and they instinctively obey the prejudice that the pervasiveness of the work is proportional to the number of observations, which I genuinely believe is an illusion. If we favor quantity over quality, then it makes me very desperate. But perhaps that's also because I come from neuropsychology, where I believe that carefully studying cases is very relevant. So I think that what we don't need is more tests or more data. We need the right ones. We need the right tests that are sensitive, and we need data points that are genuine and that we can trust and believe. And so that's why then obviously I moved back to controlled laboratory testing as it was originally done to identify superrecognizers. So if you recall that in the original Russell et al. Study, they included 3 different tests that all targeted a different sub-process or level of phase processing. So the first one was a perceptual matching task, the second one was an old new recognition, and the last one was an identification task. So if you think about the levels of processing that I mentioned at the beginning, you can see that 3 levels of processing were probed in these individuals. Now, currently what is happening, or what some authors are doing, is that they're using any test that probes any given subprocess. And I believe this to be quite problematic. So in the Phillips et al. Paper that I mentioned previously, they said that super recognizers could be identified through testing or through peer evaluation, or when a person was doing this as a profession. But when it comes to testing, they said that any qualifying test reported previously in the super recognizer literature would do. So for example, the Cambridge face memory test or the Glasgow test, the Glasgow face matching test. Whereas previously, David White and his colleagues had already reported that the Glasgow face matching test was not sufficiently sensitive to distinguish between developmental prosopagnosics and normal observers. So I would then question, why would it be valid to use a measure that can't distinguish between impaired and normal processing to identify someone who's considered as excellent or excelling at face processing? So I believe this conflation of the different subprocesses is problematic, but also when we do this, we neglect the differences in terms of test sensitivity, because one test is not comparably sensitive to another, or not necessarily. And some others have at least used one consistent measure of a given subprocess with a given test. So my dear friend and colleague, Anna Bobek, and she's actually the reason why I'm doing this work right now, she had spent her PhD looking into super recognizers, and throughout the course of her work, they took, for obvious methodological reasons, because not everyone can identify the same individuals, and the perception task used actually isn't very sensitive, they had focused on using the Cambridge face memory test as a criterion for super recognizer selection. And they had tested a large number of young British student populations, I believe. And they said that anyone who had above 95 on the Cambridge would be considered a super recognizer, and then use this as a criterion for selection. I think this is a very stringent approach, and we wanted to look at how the Cambridge face memory test would actually correlate on an individual level with performance on independent other measures. And so in a paper that we recently published, we took the Cambridge face recognition test, and we looked at other perceptual tasks that have been reported. So this is the expertise in face comparison, I think. And then this is the person identification task. So basically on the left, you have to match two images and decide whether it's the same person. And here the face is in the focus of the image, whereas on the right, the task is the same, but you have more information, and it includes background, scenery information, and so forth. So there it's more a person matching task. And then we have, oops, sorry, I went the other way. And then we had two other tests that were new to me. They had been published longer ago, but I wasn't aware of until Brad Duchenne pointed it out. I call it the yearbook test. And this was interesting because Patrick Kavanagh and two of his colleagues who were former classmates together apparently went on their high school reunion, and they thought that, okay, 25 years later, it would be a really good opportunity to quantify how good we are at recognizing personally familiar faces. And I used this matching task where you're supposed to match the top 5 young people with the bottom 10 older people. I use this as a very difficult task of unfamiliar face matching under conditions that resemble what we could be dealing with in real life. So naturally occurring changes due to aging. And then another experiment, or another task that we looked at, was the facial image card sorting task, where you have images of 40 images conveying different identities, and people are supposed to make groups of identities and put them together. So across these 15 images that you see in this case, you actually are only seeing 2 different girls, but this is a very complex task for unfamiliar observers. And we looked at 181 participants and saw that, okay, there were some people who performed very well. So the top performers in the Cambridge face memory test, we wanted to see how they performed in all of these other perception tasks. And so these point clouds that you can see here are always the Cambridge performance, but then we're flagging out, we're highlighting the top performers of the other perceptual tasks. So you can see that in both the EFCT and the PICT, the high performers there in that task did not correlate or coincide with the high performers in the recognition task. And the same thing we saw in these other two independent tests of challenging tests of face perception. So what this means is that the people who excel at recognition tests aren't necessarily those who also excel at independent tests of face perception. So people can be good at the Cambridge memory task for a number of different reasons that may not have a lot to do with face perception per se. So this is all going to show that on the individual level, the sub-processes can often dissociate. So high performance in terms of recognition doesn't necessarily mean that you also have high performance in terms of perception. And this is also something that we corroborated in a recently accepted paper with Matt Fish and Lisa Stuckey. And what we did there is we took more difficult tasks. So we looked at 4 tests of perception and 2 tests of recognition. And I won't go into all these details, but I'm happy to talk about this later. And we looked at the correlations. So again, in a fairly large sample of 146 observers, we looked at how does performance across these 6 different tasks, 4 perceptual, 2 recognition, how does the performance actually correlate? And what we see is across the board, everything correlated significantly, albeit weakly to moderately. However, we were of course interested in looking at the individuals. So what we did is we took the Z standardized scores across all of the tests, ranked the participants according to their overall performance. So we had 1 to 46, 1 being the best, 146 rank being the worst. And then we wanted to look at how the patterns across the different tasks actually changed when we look at the rank performance. And what you see is that even among the high performers, so if you look at rank 3, you can see that this person excelled in 3 tasks, but actually performed quite normal with regards to 3 others. And the same type of performance pattern was also found in low performers, where even the lowest performers could perform normally for some of the tests. So if you think about it, it could be that high performers are very similar, or they could be different because they perform highly at a certain sub-process. However, I thought or assumed that if someone was bad at processing faces, they should be bad no matter what, or no matter how I test this. And if we look at the performance similarity matrices, so if we rank the observers and we correlate each observer with each other one, we also don't find any systematic relationship amongst the ranked performances. So the highest performing individuals are not more similar to one another than the lowest performing individuals. And this is a pattern that I think is really interesting. So it goes to show that the group level correlations that we observe in large cohorts don't necessarily reflect or map onto what is happening at the individual level. And if we think about individual personnel selection or identifying cases as super recognizers, I think this is really important. And so I'm trying to provide a solution for this problem because I need to create a foundation, some kind of a basis upon which I can then carry out this work that I think is very interesting. It's worthwhile looking at high-performing people, but I need to have a strict set of criteria that I can use consistently to identify these people to make sure that I won't end up with a heterogeneous pool of findings. And so this is a framework that I've proposed in a paper that is just now under review, and I'd be happy to share it confidentially if anyone's interested. Basically, I'm proposing for myself and others to use as well, a diagnostic framework that is supposed to facilitate selection of individuals and hopefully establish some kind of an increased comparability amongst cases. And this includes 3 simple general guidelines for identification of super recognizers or superior face cognition ability. And these 3 practical guidelines pertain to the approach taken, tools used, and the reporting of the data. And so the first aspect, the approach that we adopt, I would stipulate that we need to assess face cognition at multiple levels. It's not sufficient, clearly, to only look at face perception or to only look at face recognition and do it with any given test. We need to assess multiple levels of face processing, and only people who excel across different levels should be considered as something that's unique, because we know that even normal control observers can excel at a given test. Yeah, so following the original tradition of the initial publication by Russell and colleagues, we need to assess different levels of processing, ideally each level with different tests, because the more tests we use to probe one process, the more converging information we have, and the more sure we can be that we're actually dealing with someone who is excellent or superior. And what's really important also is I think that we have a very clear conceptual framework. So we should not use the word identification and recognition and perception as synonymously, because this is really difficult in terms of communicating and creating a mutual understanding that, is a clear-cut conceptual and theoretical and vocabulary distinction. The second one relates to the use of appropriate tools. So as I mentioned before, there are some tests that are used that are not sufficiently sensitive to distinguish between developmental prosopagnosia and normal behavior. So this is something that should definitely not be used to identify superior performance. And also, I believe that we should only use procedures that are methodologically sound and that have been peer-reviewed and that are reproducible. So we need sufficiently sensitive, validated, and reproducible methods and tools. And finally, I really want to make a call for a consistent and cross-study labeling of cases. I have personally come across individuals who have not been reported consistently across studies, across publications. People have used different acronyms, and this, in my opinion, is not desirable because it actually leads to a loss of information. And this is problematic, and it doesn't follow the tradition in neuropsychology where we have a case, and this case is consistently built over decades of work. There's so much that we wouldn't understand about the brain if HM or other cases would have not been consistently referred to and reported as the same person. So this is really important in my opinion, and it's not commonplace, even though for a lot of people it is quite intuitive. And currently I'm using 2 specific diagnostic criteria, namely that people have to have consistently high performance across a range of different tests, and that they place amongst the top performers. So I don't think it's advisable to have a clear cutoff saying everyone has to have above 95 in the Cambridge, but they have to achieve high performance in a relatively a large, diverse cohort, and they should place amongst the top performers. Because if my cohort is comprised of 25-year-old females, the cutoff will be different than if I'm testing a very heterogeneous cohort that's more representative of the entire population. So I don't believe that clear cutoffs are the way to go, but it's ranking in terms of a large number of varied observers that's important. So I would also like to say that these diagnostic criteria that I'm using and that I'll refer to right now are not set in stone. So this is currently my best guess, and I'm willing to adopt new and better techniques and procedures as I'm presented with them. So if you have better tests or suggestions on how I could optimize things, please do let me know. But currently what I'm using are these 2 really challenging tests of face perception, which involve unfamiliar identity matching across conditions that are ecologically valid, and the Cambridge face memory test. And this is because we know that performance in normal control samples does not correlate very well across these tests, and that, you know, there's a large separation in terms of the profiles of behavior performance patterns that we see. And so over the past 4 years, I've been testing every single individual who has contacted me seeking to be assessed as a super recognizer. I've also been very fortunate to have the opportunity to test again super recognizers that have been previously published by Anna Bobak and her colleagues. And I've also tested numerous police professionals, forensic examiners, or other people who were reported in the media that I contacted because I thought, hey, you might be an interesting case. And so over the past 4 years, I have identified 40 cases using these criteria who I believe to be unique and superior relative to what I have observed so far. And yeah, so these 40 cases are basically my foundation of research, which I'm presenting in that paper, which is currently under review. And we see that these individuals, if we look at their individual performance across the tests that I just mentioned, we can see that they're systematically at the extreme ends. Obviously, that's the selection criteria that I impose. And if we look at the relationship across all of these tests, how these two correlate, all the pairwise combinations, this is what it looks like. And this is just kind of a primer of looking at all 3 dimensions together. So we see that the super recognizers that I've identified, they're consistently out of the normal range. Now, I'm not going to say whether super recognizers are something unique, whether they're something special, or whether they're just the extreme of the continuum, which I would also be happy with. I'm just saying that this is how it currently looks. And whether there's something special, I can't say yet. But this is something that we're looking in the future. And if we look at the performance similarity matrix of super recognizers and controls who are ranked according to their performance. So remember the nice representational or performance similarity matrix that I presented, you can see this. So we have the 40 super recognizers and 140 control participants who are ranked according to their performance. And amongst the controls, who are basically 40 to 220, you can see again that there's no systematic relationship between the individual test performances, whereas obviously, because this is the selection criteria that I impose, the super recognizers seem to be more closely correlated and they're more similar amongst this group. So I think I've already been going for a long time. I can give a quick outline if you want, or we can stop here and discuss. I don't know, Sharon, what do you think? Or all the others, please.
I don't know, well, we can do both. Well, I've got lots of questions. I assume others have too. So I don't know, how long is this outlook?
It's like 5 slides where I'm really just briefly touching upon it. And
yeah, okay.
Cool. So as I said, this was all like behavioral work that I was doing as kind of like a baseline so that then I can do what I'm actually interested in. So looking at what is different in the brains and what are the mechanisms underlying superior recognition or superior processing of faces. And so now I'm going to give an outlook, which I already also give in the paper, on the stuff that is currently in preparation so that we soon hope to submit. And the first one relates to ocular motor behavior in super recognizers. So to my knowledge, currently, there are 2 studies published that have looked at ocular motor behavior in super recognizers. However, in terms of the analyses, I believe there are some questions that I don't have yet answered, and also the type of statistics that they used, I believe might have muddled some individual differences that I would be very interested in. And so what we are doing in collaboration with my colleague from the University of Gießen, Benjamin de Haas, is this is tagging on to his recent publication in PNAS, where they found that individual differences in visual salience are very consistent, and they're related to preferences for certain semantic dimensions. So what you see here is 2 individual observers. So basically the blue squares is observer 1 and the orange squares is observer 2. And each observer has a very consistent preference in terms of their fixation behavior for specific semantic categories. So the person in blue really likes to look at objects that are being moved or that convey motion, and does not focus a lot on faces, whereas the orange observer does. And so these individual differences in ocular motor behavior that are related to semantic categories are obviously very interesting. And so what we are looking at and what we're currently preparing is a paper where we looked at whether super recognizers have abnormal fixation biases towards faces. And I can say that the current findings suggest that they do. And this is really interesting because this already shows at the first fixation on faces that are embedded in complex scenes. So it seems to be a very, very quick and yeah, an involuntary process that might already be the basis for more proficient perceptual processing. The second group of work that we're looking at is some psychophysical experiments where we were looking at certain sources of information within a face that might be processed better by super recognizers. So the first one is this notion of horizontal and vertical structural sensitivity. So there is some work that I did with Matt Pachai where we found that personal familiarity with faces increases sensitivity to horizontal structure. What this means is that if you look at the very degraded faces on the left, the top ones are vertically filtered, only horizontal information is contained, and on the bottom vice versa. The more you are familiar with a face, the less horizontal information you actually need. So you see increased horizontal sensitivity for personally familiar faces. And so our question was, are super recognizers better because they can process this information more proficiently? It doesn't seem to be as easy as that, I can say. The other experiment that we did in the context of this project was looking at spatial frequency tuning. So we know that faces convey high and low spatial frequencies, and it could be that, you know, individuals who are superior are specifically tuned to different types of this information, or maybe they use it more flexibly. And this is relating to a paper that I did, or something that I reported in the discussion of a paper from when I was back in Glasgow. I looked at personally familiar face identification across simulated viewing distances. So what you see on the bottom is the information on the retina, so the retinally available information that is provided by images that simulate different viewing distances. So the images were always downsampled and convey and really super small at some point where you thought, yeah, I cannot even see that there's a stimulus on the screen. But you can see that individuals who are familiar with faces or identities actually need very little information to process facial identity for identification. And so this is what we were looking at in super recognizers. And it seems to suggest that there is increased sensitivity to low spatial frequency information. Then another thing that we're working on, and which my PhD student Chris Turner, who's I think listening, is preparing currently, are related to the effects of stimulus memorability. So Wilma Bainbridge has created this amazing research project around looking at intrinsic memorability of images. So that certain images, faces, complex scenes, whatever, differ in terms of the memorability that they have. Some are highly memorable and others are highly forgettable. And we were interested in looking at whether super recognizers are better, for example, with highly forgettable images, or whether they show increased recognition performance for memorable or on average memorable images or faces. So yeah, are there abnormal memorability patterns in super recognizers? And lastly, something that I'm preparing now with Anna and hope to publish soon, is looking at whether the performance that we see in the lab actually translates into security critical settings such as criminal investigation or perpetrator identification between videos and lineups of perpetrators. And here I was really interested in seeing whether people that we identify in the lab through our experimental procedures, do they actually outperform people who do this professionally? And are they better than, say, a large proportion of civilians? So like wisdom of crowd approach. And so yeah, these are the type of questions that we're pursuing immediately, and then obviously in the future there's more to come, but that's kind of where we're at right now. So to summarize, I hope that I've convinced you that we need better diagnostics and a more theoretically founded approach to super recognizer research, and this is important so that we meet expectations from government and police practitioners. And the things that I mentioned in terms of the work that we currently have ongoing, I'd just like to point out that once all of these things are done, the next step is obviously to look at the neural basis of superior processing of human faces. And with that, I'd like to thank you all for your attention, again, for inviting me. This is amazing. I'd love to come back and talk about the findings sometime later. And obviously, I'd like to thank my funding body, my lab, all of the people who volunteer and contact me from the public, the collaborators, and everyone from the police people too. And lastly, a shameless plug for a special issue. For those of you interested in case studies and special populations and who think this is something that is really important and that needs to be pushed more, Ella Streamerman and I, we are organizing a special issue on deep data, or the future of case studies and special cohorts. And we would very much like to give you more information about this call and be very happy to hear from you in terms of contributing to this. Okay.
Thank you very much. Let's all thank Meike for this, amazing talk. Very intriguing.
Mm-hmm. Thank you. Okay, I'll stop sharing my screen and so I can see.
It was, well, I'll start with the first question, but I'm sure other people have lots. So I'll start with the first one out of, I don't know how many I've got. What is the expected prevalence of this in the population of the SRs?
So I always hear 2%, but this 2% I think is really interesting because what it reflects is the amount of people who perform above a certain cutoff with a certain test. So obviously, if I use a different test and I change my cutoff, I'm going to have a different prevalence. So in my opinion, prevalence estimates only make sense in the presence and utilization of a biological marker. If we look at the prevalence of schizophrenia or something else, we can have genetic studies or twins that, we'll have some kind of an objective basis based on a behavioral test where people cannot be repeatedly tested and looking at the reliability, all of these measures. I would be the last one to give a prevalence rate based on behavioral performance and tests.
Okay. So, thank you. So I'm letting others also ask, and if they won't, I'm ready for my next questions. So feel free to ask. Okay, so another question that I have is, you've showed that there are, that on the specific subtests, they can be, even if you are at the very high percentile, you might not be in that area if you are looking into recognition and then perception. And these super recognizers are, as far as I've seen, fall within the upper percentiles across all of them. So you think that if somebody uses, let's say, only one of these methods, and they find a subset of people who are at the upper, let's say, 5%, that does not mean that they would qualify. It's just ruling out the possibility that they may, or that they are not. So they could actually be or not be. If they are not at the top percentile, they are not super recognizers, but the other way around is still.
For me, it's kind of like, if you have one test it should serve as a screening to then look at additional tests. This is what we do in clinical cases as well. You know, if someone has, I have the suspicion that someone has dementia or mild cognitive impairment, I do one test, and then I don't say yes or no, I do further tests. You know, we need to have converging evidence that will strengthen our hypothesis or an impression that we have. And I don't see any reason why we shouldn't have that same approach to looking at unique cases. I think the reason why people don't do it is maybe twofold. A, there's nothing to lose. Who's going to lose if I'm incorrectly labeled a super recognizer?
Yeah.
There's no lobby. No one's getting hurt. Yeah, the only one who would get hurt is if a police agency or security someone would have expectation towards my professional performance, and then I wouldn't perform. But there's no, I mean, so it's a resource question, you know, but it's not the same as I'm telling you you're HIV positive and you're not. You know, I mean, obviously the implications are way much more severe in case of false positives. So I think it really depends on what are we looking at? Is this just, oh yeah, I'm curious to see how good I am at a given test? Yeah, call yourself a super recognizer.
And what about individual, like, subjective experience? Because a lot of prosopagnostics are not only diagnosed as being prosopagnostic based on the Cambridge Face Memory Test, but rather based on their subjective experience that they, in familiar settings are managing okay, but then have problem in family gatherings or stuff like that. So do you also take that into account, or would these be indicative for super recognizers as well? Or is that something that's not, I mean, would that not correlate with, your tests?
Yeah, I think that's an excellent question. So also I want to then point towards a publication about self-report or self-assessment using questionnaires that have been developed. And to my knowledge, what Anna Bobak and her colleagues found there is that in people who have been diagnosed as super recognizers, who have received feedback that they are good, they have a better insight into their own capacities. Whereas in normal subjects, they find it difficult to estimate whether they're good or not. But I do think that at the extremes of a performance continuum, these people will have accumulated over the course of a lifetime a certain number of experiences that will probably lead them to more accurately assess their own capacity, like you say, with developmental prosopagnostics. I mean, I remember a mother, who could not distinguish her twin or couldn't even recognize her daughters at a kindergarten because they all had capes on because they were painting with paint and whatever, and that is not a normal experience. And likewise, sorry, there's a helicopter. Likewise, the people who contact me, there's certainly a given bias that those who reach out and seek assessment and who write an email to me, those are probably the ones who are quite sure of themselves and have already had cases where they recognize someone and their social group, their network is like, oh my God, how could you do that? There's some kind of feedback that you can get. So I think in normal observers, the self-assessment isn't necessarily representative. However, in the extreme cases, I do think that there's something to say about the value of personal experience report. Very long answer.
Okay, sorry. I'm also opening the stage, but then if there's nobody who's, I'm gonna continue. Okay, here I go. So about the reaction time, I mean, most of these tests are evaluating accuracy, but for example, at least with the Cambridge Face Memory Test, you don't have limitations. I mean, the stimulus is there until you provide a response, and people can vary a lot in their ability to do the task, or, quickly or slowly. It doesn't mean, it doesn't necessarily mean that they'll be more accurate if they take more time. If somebody is probably super recognizes, do it accurately and quickly. But my question is whether you looked maybe at the speed accuracy trade-off, because maybe the fact that people are scattered in the other domains have to do with the fact that they maybe took longer to achieve higher accuracy. But I'm thinking about this, whether you examined RTs or speed accuracy trade-offs and measures.
So I think this is an excellent point, and it's one that I have made, especially when it comes to prosopagnosia. You know, we need to consider speed accuracy trade-offs. That is, in my opinion, the reason why people can achieve normal performance on the Glasgow face matching, because they can take a long time to get a normal accuracy level. I think it's really important to distinguish between, again, the levels of processing. So you mentioned for the Cambridge face memory. Yes, it's true. You have an unlimited amount of time to look at the triplet and say which one of these three is Bob or Joe or Bill or whoever I had to learn. But you can have as long time as you want. That's not going to, you know, consolidate or encode that Bob better retrospectively. So there, it's like, I think in recognition tasks, you either know if you've seen it or if he's there or not. So I think in recognition task, with a delay between encoding and recognition performance, reaction times are more likely to not be informative because waiting doesn't help. In fact, it might actually make the other memory traces less accurate if you take more time on an individual trial. However, yes, of course, in perceptual matching tasks, especially in simple perceptual matching tasks where you only have two to compare, I think it's extremely important to look at reaction times. And that's actually what we also did when we were using the EFCT and the PICT, contrary to what David White and his colleagues did. So we actually looked at the combination of accuracy and reaction times to take into consideration these speed accuracy trade-offs. My impression is, so for the two tests that I use, the yearbook, the young to old matching, there I also don't think that reaction times is informative because it's already really difficult. You've got 5 to 10, they're black and white, super bad resolution, aging, unfamiliar faces. It's difficult for everyone. I don't know of anyone who doesn't need at least a half an hour to do this test. And on average, people get 8 of 35 items right. Yeah. And the highest performing super recognizer got 29. Yeah. So there's a difference. And the same with the facial image card sorting task. I consciously don't want to put people under pressure. And I actually watch them while they're doing it. And sometimes people actually get a worse score because they change their criterion. You know, the longer you look at unfamiliar faces, the more you might pick up on similarities, but the more you might actually also choose a serial feature-based style, which would then lead to more errors. You know, so I think we really need to consider reaction times where they're most appropriate and where trade-offs are most likely. And I think those are the easy conditions. So face-to-face matching or frontal face to frontal face. You know, the more simple a choice is, the more important reaction time consideration is.
Wonderful. Thanks.
I want to
go?
one
Yeah.
one question. I wonder, sorry. I wonder if there is a relation between super recognizer and the literature on savant processing or savant people who have other superior ability. That I recall that there is a debate about the reason for the savant abilities, and some say that it's like experts. They are obsessed with some specific interest. And maybe that applies as well for faces. Some people have extreme interest in faces and become experts or something like that.
Yeah, I think it's super intriguing, and I think it's a really interesting question. I can't respond to it with, you know, I can't give a definite answer. The only thing is that I can say is amongst these 40 people, there are definitely some people who say, I've always liked looking at faces. I've always been attracted to them. This is the first thing that I look at. Others say, I avoid crowds. I feel overwhelmed. It's as if I can't not process the faces. It's like it's too much information and it's actually fatiguing. There's another guy who does a lot of fishing, and he's extremely good. I would consider him like comparable to those bird experts, and I think he's a very visual type of person who looks at fine details and who can distinguish exemplars across multiple categories very well. However, I think that so just to say that the inter-individual variability amongst these people is probably comparable, if not the same, to what we find in the normal population. So you'll find some people who are maybe savant-like, but others who are just like, nah, you know, my profession is I'm a painter. I've always liked looking at dealing with visual stuff, but other than that, I've just been normal. Or other people have asked, like, do you think it correlates with the population of the city or the place that a person grew up in? Maybe the more faces you saw during development, the better you are later. Also doesn't seem to hold. So we've got some people who grew up in a Swiss village with like 2,000 people, and others who are like from Zurich. And I don't know. I think these are really interesting questions, but I think we need even more people to look at.
They are all the same, like the same performance, or you get some super recognizer, you know, some the extreme, and they are the real savants or something.
Well, I mean, maybe, but then the question is obviously, I mean, people have used the word super duper recognizer. I am not using that, yeah, formally. Certainly amongst the good ones, there will be even better ones. I completely agree. I then just wonder, how capable are we as normal people to devise tests that are capable to identify these people? Yeah, it's already difficult enough to put ourselves in the mind of someone who has a deficit. How are we supposed to develop test items that are good to identify people that are better than us? I don't know. It's like, all just to say, I think we need neural objective measures. So that's what I'm more interested in, because then it should be reliably measurable at the level of the brain.
Yeah.
Okay, I'm continuing. As long as somebody stops me. I wanted to ask if you have any idea if they have, or maybe they don't have, the other race effect, the super recognizers.
Mm-hmm. Yeah, so I think there are 2 papers on that, and the evidence is kind of, some say normal, and others are like, yeah, they're better for other race faces. I could see both. For me, both situations and scenarios are entirely plausible. Someone could be better with ethnicities that they haven't yet been exposed to because of something that I don't understand with my normal ability, or they could show an exaggerated own race or own ethnicity preference or bias. I don't know. And I think that the heterogeneous findings might be due to the fact that the diagnostic measures to identify the people are not consistent, or maybe lead to us identifying different types of people. So this is also one thing that I would really be interested in looking at, and especially also in the context of the work with the police officers, because there we have access to large databases of images of people from different ethnicities, and we can actually look at it systematically under real life scenarios, rather than just using Caucasian and Asian or Caucasian and African. You know, like, I think we need to also look at the subtleties. Yeah.
Okay, I'll stop here with my questions. If anybody else has more questions, very welcome to ask. You can unmute yourself and ask. And I do want to say that since this was a pleasure, I'm going to coordinate with you another talk next year.
Awesome.
Yeah, would be great. So I'd like to suggest that we all thank Meike for this wonderful talk.
Thanks for having me. Thank you.
Yeah. A great ending to our seminar series this year. We're going to take a break from now until September for the next month. So I want to wish you and everybody else a nice summer vacation despite the corona. And thank you very much. It was very interesting.
Thank you. Thank you so much for having me. And anyone who has any questions or suggestions, please feel free to contact me. And I look forward to speaking with you again soon.
Lovely. We also look forward to hearing your next talk.
Thank you.
Thank
Bye.
you, Meike.